Welcome to some background trig information. We're going to begin with the unit circle. This should look familiar to you. If you don't have it memorized, you should have it memorized. The things that people would forget is that the x value refers to the cosine. Because remember, cosine is the left-right position on the unit circle. The y value refers to the sine, because sine talks about the height. So you'll notice cosine is positive here, cosine is negative in the second quadrant, cosine is negative, cosine is positive. Sine is positive, sine is positive, sine is negative, sine is negative. Let's talk about the tangents. The tangent is always the sine over the cosine. So using the unit circle, you should be able to find the tangent values. At any given position, you can find the tangent values by writing the sine over the cosine. That looks messy, so I go back and I write my division sideways. Then, to multiply by the reciprocal to solve, I would get my tangent value. Notice that the 2's cancel out. Notice that the denominator is always 2. The denominators will always cancel out. I cannot leave my tangent like this. I need to rationalize, so I get root 3 over 3 would be the tangent at this spot. Remember how I just said the denominator is always 2? The 2's will always cancel. That creates a quick trick because I can find the tangent value by doing the sine value over the cosine value. Don't forget your points go backwards on this side. So sine over cosine would give me my tangent, and then I just need to rationalize. I have root 3 over 3. I always stick the negatives in the numerator so that I don't lose them. So you can find your tangent values by sticking the sine over the cosine numerator values. With that being said, let's go on to some other review. Here's some more background information, which is how do we solve this equation? Well, we solve by taking the square root of both sides. And then x equals plus or minus 3. A lot of people forget the plus or minus, but remember, negative 3 times negative 3 equals 9. Positive 3 times positive 3 equals 9. How do you solve an equation such as this? This goes back to M3 and fireworks. Once something is in factored form, you can set each factor equal to 0 to solve. Because if this factor equals 0, when you multiply, the entire item will be 0. If this factor equals 0, when you multiply it by this number here, the entire thing will be 0. So, to solve this equation, x equals 0 and x equals negative 3. Remember, if I distribute, this is a quadratic equation, and it happens to have x-intercepts at 0 and negative 3, and that is what it means to solve the equation. Anyways, that's just going back to your fireworks experience. So here, I could solve this. Again, it's in factored form already, and I would solve this equation. X is negative 3 and x is 4. These would be solutions, also known as roots, also known as x-intercepts. Okay, so those are some different synonyms you could use. This one I cannot solve as is. I have two options for solving it. First, I can factor it, and that's the method I'm going to show you first. So I would say 5 and 2, x and x, a negative 5 and a positive 2. So factored form would be x minus 5, x plus 2, and that equals 0. Now I need to take each factor separately, set it equal to 0, x equals 5, x equals negative 2. Whenever possible, I factor, just because I tend to be faster at factoring. But this is also quadratic, so I can use the quadratic formula. The quadratic formula is the x-intercepts, roots, solutions can be found at negative b plus or minus the square root of b squared minus 4ac all over 2a. A is the coefficient here, b here, c here. So to set that up, I get a positive 3 plus or minus 9, negative 3 squared, minus 4 times 1 times negative 10 all over 2 times 1. Doing some math, that gives me 49 all over 2. Then I get two solutions at 3 plus 7, square root of 49 is 7, over 2, and 3 minus 7 over 2. 10 divided by 2 is 5, negative 4 divided by 2 is negative 2. Again, my roots are at 5, 0, and negative 2, 0, which is the same as I got when I factored. All right, so this one, what I'm going to do first, it is not set equal to 0, so I need to set this equal to 0 so I can even begin to factor or use the quadratic. I am going to use the quadratic formula. I'm not the quadratic, sorry, I'm going to factor. This is x, and then I'm going to go, what numbers, how can I get 12? What about 4 and 3? 8x, 3x. If this is a negative, I'll get a 5x. So I have 2x minus 3 and x plus 4 equals 0. So I set each factor equal to 0, and x equals 3 halves, and x equals negative 4. Those are my solutions. Now a necessary trig recap. What is secant equal to? It's the reciprocal of cosine, so cosine would be a flip. Remember, this is 2 over 1. If cosecant's 3, sine is 1 over 3. Okay, sine of 30 equals sine of 390. Why? Okay, well, here's 30 degrees. 390 is a full 360 plus a 30 degrees. What other angles have the same sine value? Well, if I add another 360 to that. So 360 plus 390 gives me 750. 750 would have the same sine value. Add another 360. That'd be 1,110 degrees has the same sine value. So every angle, 30 degrees plus 360 degrees, would have the same sine value. But that's not all, because the sine value at 30 is 1/2. The sine value at 150 is also 1/2. So the sine of 30 is the same as the sine of 150 degrees, or 150 plus 360, or 150 plus another 360, or 150 plus another 360, for any multiple of 360. Okay, so if I do 360n, this shows for any multiple of 360. So I could add 360 twice, I could add 360 4 times, 5 times, does not matter. So let's see here. Sine of pi over 3, let's find pi over 3, it's right here. The sine of that is equal to what other angles? Well, the sine of pi over 3 is equal to the sine of pi over 3 plus 2 pi. 2 pi is a full circle. It is equal to the sine of pi over 3 plus another 2 pi, plus another 2 pi, plus another 2 pi. Let's just condense that to a much simpler format. Pi thirds plus 2 pi n. Okay, now let's not forget the sine at pi thirds is equivalent to the sine at 2 pi thirds. At 2 pi thirds plus 2 pi. A full circle, or another full circle, or another full circle, or n full circles. Cosine of pi halves. Let me clear my screen, I guess. Cosine of pi halves is right here. Cosine is here. Where does that value repeat? It repeats right here. Is that a full circle? Nope, Miss Leonard, it's not. That would be adding a pi. What if I added another pi? Would I get back to the same spot? Yep. What if I added another pi? Would I get back to the same spot? And another pi? These are all the ones it's equivalent to. So I abbreviate that as pi n. The cosine of pi halves is equal to any angle of pi halves plus pi n, where n is a whole integer. Okay? And that is the background information.